Alright, today we are starting to look at vectors. You should have a packet in front of you with these problems on them. Alright, first thing we're going to look at is just what a vector is. So some quantities such as force, velocity, those things have magnitude and direction. So something that has a magnitude and a certain direction that it's going and counts as a vector. So a lot of times when we talk about vectors, we use u, v, w, and they are bolded when we talk about them. So suppose u is a directed line segment from P to Q, where P is at 0, 0, and Q is at 3, negative 2. So from P to Q means I'm going in that direction. Represent the vector u on the graph in two different ways and call them w and v. Right, so this vector, what makes it the vector is the magnitude or its length and the direction it's going in. So this one started and went down to right 3, so I could start up here and go down to right 3. That could be one vector. I could start over here and go down to right 3. That would be another vector, v. Those would all be the same because it doesn't matter where they're located, it just matters how long they are and in what direction they're going. Alright, so magnitude. We're going to start with doing the magnitude of u, and we use that double bar to find magnitude. Your formula for magnitude, like I said, it's your length, so it's just your distance formula. So P1 minus Q1 squared plus P2 minus Q2 squared. If it works for you to do distance formula, do it that way. If you want to think of this line and make a right triangle with it and do Pythagorean theorem, that is up to you. They are the exact same thing. So when I do this, my difference here for horizontally would be 3, so I have 3 squared, and vertically is 2 squared. So that's going to be the square root of 13. You can do the same thing to find the magnitude for v, which should be square root of 13 as well. And for w, which again is going to be the square root of 3 squared plus 2 squared, which is radical 13. That's the first thing we look at, is how long it is. Then we look at direction. And for right now, we're just going to do it like we would slope. So for you, your direction is down to right 3. For v, we went down to right 3. And for w, we went down to right 3. So they all have the same magnitude and the same direction. We will get more into direction angles a little bit later, but for right now, it's just the slope for when we're doing direction. The last thing is component form. So for component form, for u, you're going to do q1, minus p1, comma, q2 minus p2. So what it basically is your horizontal change and then your vertical change, just like it would be for points. We do the horizontal and then the vertical. Make sure when you do this, you're doing your terminal point minus your initial. So that's what I'm doing, where I ended minus where I started to get my component form. That way it'll show me the direction with that as well. When you do component form, you use these brackets. That way we know it's vectors, not a point. So for u, horizontal was 3, vertical was down 2, so 3, negative 2. For v, my horizontal is 3, my vertical is down 2. And for w, it's going to be the same thing. 3, negative 2. Again, the first number goes with horizontal, the second number goes with vertical. Show that they are the same. So we've already done all of the work to show that they're same, but if they ask you, or if I ask you to show that two vectors are the same, you need to show that they have the same magnitude and direction. So you'd have to show me both, which we already did. There are some operations we can do with vectors. The first one is scalar multiplication. So if you let k be a real number, then k times vector v, you would be able to take both of your components and do k times each of those. So k times v1 and k times v2. So for example, if k equals 3 and my vector equals 3, negative 2, just like it was from a minute ago, then kv would be 9, negative 6. Just multiplying the 3 by each of those. You can also add vectors, which would mean you could also subtract them as well. So if I have vector u plus vector v, I take the first component of vector u plus the first component of vector v, and then the second component of vector u plus the second component of vector v. So for example, let's say v equals 3, negative 2. Let's make u 4, 3. So if I ask you to do u plus v, then for the first component, I'm going to do 4 plus 3. For the second component, I'm going to do 3 plus negative 2. So 7, 1. Same as always, adding and subtracting. Just make sure you're following the order, especially with subtraction. Alright, now I'm giving you vector v and vector w, and I want you to graph each of them. So v is negative 2, 5. If I'm doing 2v, I'm going to do negative 4, 10. And just to make these easy, I'm going to go ahead and put them all in this, starting from the origin. So I go left 4, up 10, should be about up there. Make sure with your vector, one, try to make them straight on an awkward surface, but you have arrows so that I know which direction you're going. W minus v. So this one I'll kind of show you with both vectors here. W is 3, 4. V is negative 2, 5. W minus v means I'm going to take W, and then I'm going to put this v over here going in the opposite direction. So right to down 5. So this would be my negative v. The actual vector of W minus v should be this one right here, which based on this looks like it's right 5 down 1, and we could check that with W minus V. That would be 5, negative 1. But when I'm doing subtraction, I can just connect. I do the first vector, put the second vector from the end of that one, and then if I connect them, that's my third vector. V plus 2W, so same thing. I would draw V. I would draw 2 of my W's, So v is -2, 5. I'm going to add to that 2w, so 6, 8, which this does go off of the chart a little bit, but I should end up with 4, 13. So v would bring me back here, 2w would bring me up here, which means my final one should be right about there. So 1, 2, 3, 4. Yep, 13 is right up there. Oh man, I apologize for that. I'm sorry, that's an awful line. That should be a straight line like that. I can't get the thing to work correctly. Anyways, you can do your vector addition, subtraction, those things by drawing each vector that it says, connecting them end to end, and then just connecting the start to the final finish. Or you could do the actual vector operations and get the component form and then draw that vector. One other thing we're going to stop there for today, and we'll pick up with the unit vector and everything tomorrow.